Welcome to the lecture on analyzing risks or risk analysis. In the last lecture, we focused on identifying risks and we tried to identify all the things that could go wrong. Now that we have our list of risks captured in the risk register, the next natural step is to analyze those risks. The fact of the matter is that all risks are not equal. For instance, the risk that your website, which serves millions of customers around the world, gets hacked is far more serious compared to, let's say, the network printer stops working for a few hours. The implications are enormously different. Therefore, we need a way to quantify exactly how serious a risk is. And that's what we're going to cover in this lecture. Now, there are two important concepts that you need to understand when analyzing risks. So, the first one is likelihood. And this defines how likely is that the risk could actually materialize. For example, the risk that a random meteor hits your headquarters building is extremely unlikely or rare. However, the possibility that an employee clicks on a phishing email is much more likely. Therefore, we really need to quantify what is the likelihood of a risk to materialize. Because let's say if the likelihood is 1 in a billion chance, like the example of the meteor, then for all practical purposes, we can safely ignore that risk and instead focus on risks that are much more likely, such as a phishing attack or hackers infiltrating your web application due to a known vulnerability in the code. Introducing the likelihood aspect helps us focus on things that could go wrong instead of things that would probably never go wrong. The second important concept that risk analysts need to understand is the impact, which means how bad would it be if it does happen. For example, getting your website hacked, which serves millions of customers, would have a huge impact compared to, let's say, the network printer stops working for a few hours. Thus, we need to cater to the impact that a particular risk would have on our organization if it actually materialized. Once again, this helps us focus our energies on risks that are much more likely to cause significant damage. So, formally speaking, risk is equal to likelihood multiplied by impact. This formula accurately captures both the important metrics. So, the likelihood, which is how likely is that the risk would actually materialize, and the impact, how bad it would be if it actually happened. So both of these are very important terms, and by multiplying these, we achieve a risk score, which gives us a pretty good idea of the level of risk that this particular threat poses. Now, there are different scales that can be used to assign scores to likelihood and impact. The usual industry standard is to use a scale from 1 to 5. So for example, in terms of likelihood, so if the likelihood is rare, then we assign it a score of 1. If it is unlikely, then we assign it a score of 2. If it is possible, we assign it 3, for likely 4, and for almost certain 5. So as you can already see, we increase the numbers as we go down from rare to almost certain. Similarly, for the impact also, if the impact is negligible, we assign a very small score 1. If it is minor, then we have 2, if it's moderate 3, major 4, and catastrophic 5. So as you can already see, a risk which is rare and which is negligible is going to have a very low score compared to a risk which is almost certain in terms of likelihood and the impact is catastrophic. So 5 multiplied by 5, it would be 25, much higher. But let's do some actual calculations so that the concept becomes crystal clear to you. So let's calculate the risk score for a phishing attack. So as always, risk is equal to likelihood multiplied by impact. So in terms of likelihood, what do you think is the likelihood? Is it rare, unlikely, possible, likely, or almost certain? Let's say we assume that it is likely. So we are going to assign it a score of 4. What about the impact? Would the impact be negligible, minor, moderate, or major? Let's say we think that it would be a moderate impact. So we'll use the score of 3. So in this case, it would be 4 likelihood, 3 for the impact moderate. So the risk score would be 12. Now let's do another example. Let's calculate the risk for a meteor hitting your data center. So once again, risk is equal to likelihood multiplied by impact. So what do you think would be the score for likelihood? Is it almost certain, possible, or rare? I would say it's very rare, right? So we can assign it a score of 1 for likelihood. What about impact? Well, if it actually hits your headquarter building, it will be gone. So it will be catastrophic. Okay, so we'll pick 5. So 1 multiplied by 5 is equal to 5. Now here's the very interesting thing. Now meteor sounds very dangerous, and obviously if it actually hits your data center, it is going to destroy everything. So the impact is very high, but it is very unlikely to occur. So when you assign a small score to either of these metrics, the total score becomes very less. Compare this with phishing. The impact is actually moderate, 3 compared to 5 for the meteor, but it is more likely to occur, 4. So that's why the total impact is much higher. Now, how are likelihood and impact actually determined? So we did discuss some examples in which we said, for example, phishing is more likely, meteor is rare, impact is moderate for phishing, catastrophic for meteor. But these are educated guesses, right? But in real life, you would have to have some sort of concrete data to back up your decisions. So the first point that I would like to highlight here is that we previously used the scale of 1 to 5 for both likelihood and impact. Just bear in mind that this scale of 1 to 5 is a common practice. In reality, some organizations may choose to have more finer controls. For example, they may use a scale from 1 to 10, which introduces more levels of granularity, or they can be less granular. For example, some organizations may just use even fewer levels, like 3. So, having understood that, the next logical question is that while we understand, for example, phishing attack being likely in terms of likelihood, and moderate in terms of impact, how did we actually arrive at this precise conclusion? For example, why did we not pick possible or almost certain here, or minor or major here? Why did we pick moderate here, and why did we pick likely here? How do we distinguish between these finer shades? The answer is that there are several data points that you can use. So one popular way which can help you decide which number to pick is by leveraging historical data, which includes past incidents and industry reports. To give you an example, let's say a company A's past incident records indicate that there have been 50 plus phishing attempts on its employees in the past year. In this case, you can pick almost certain or number 5 because past records indicate that phishing attempts are very likely to continue. Similarly, for impact, let's say for a different company B, you are unsure of what number to pick for impact for a ransomware attack. In this case, let's say you read industry reports about the damage that has occurred to other companies working in the similar industry and having a similar size, which had a ransomware attack. And in those cases, the report says that generally the impact is major. So in that case, you can pick score 4. So historical data can make these decision choices a bit more concrete. Another way in which you can pick the scores for likelihood or impact is by using expert judgment. For example, you can consult security leads. You can also consult threat intelligence reports. There are different platforms who keep on ranking different types of threats and the impact and likelihood that they have. Another way is to use vulnerability scans, penetration test results. So all of these different data points are going to help you make a more concrete decision. However, there is one thing which I would like to clarify, that despite having all these data points like historical records, industry reports, expert judgments, eventually risk calculation is still a bit of an art, and there could be situations when there are minor variations based on the person who is carrying out the risk assessment. However, generally speaking, the results would still end up similar. The reason will become very clear to you when we discuss the next phase, which is risk evaluation. Because risk scores that are very close together will end up in the same macro category. For example, both risk scores of 14 and 15 may be classified as moderate risk. So you could have like big macro divisions like 1 to 9 is low, 10 to 15 is high, and so on. So tiny variations are okay as long as you are trying to capture to the best of your capabilities the risk score. Now moving on to the risk register, we previously saw that after the end of identifying risk phase, we basically filled out these two columns, okay, risk ID and risk description. At the end of analyze risk phase, we're going to fill out these four columns. Now assets affected is an interesting one. Some of these could be filled in the first phase if it's very straightforward. However, for some risk you need to analyze a bit and then list which is the actual system which is impacted. But more importantly, in the risk analysis phase, we are more interested in filling out these scores. Okay? Likelihood, impact, and the final risk score for each of these risks. Okay, so for this risk, we're going to fill it. For this risk, the same thing. So once again, just to recap very quickly, the first phase was identifying risks or risk identification, in which we tried to identify all the possible risks. In the analyze risk phase, we basically tried to assign risk scores to each of these risks so that we have a better idea of understanding which is a more dangerous risk and which one is safe or moderate. In the next phase, we are going to discuss more details on how we can actually cluster these different risk scores into fewer categories.